Please write in mechanism. CH3. We are using a mechanism of CH3, CH2, and OH. So in the presence of H2SO4 at 413 Kelvin, this will give you CH3, CH2, oxygen, CH2, and CH3. Right? Now, the first step in this particular mechanism is the protonation of alcohol. By the way, you can also think about like why the protonation of alcohol is the initial step, and this is because the H2SO4, which is sulfuric acid, the sulfuric acid will be providing a lot of H plus ions, right? So we will have a very electron poor side, that is the H plus ion. It will be not having any electrons. So it will be searching for electron rich species, and the oxygen's lone pair will be the perfect candidate for that, right? So the oxygen's lone pair atom will attack on the H positive, and this will give you the protonated alcohol. So the protonated alcohol will have two hydrogen atoms attached with the oxygen atom of alcohol. So this hydrogen was already there, and there is one more hydrogen now, which gives a positive charge on the alcohol atom. Now this water, I mean, you can see the formation of water molecule, but it cannot happen right now because 1 degree alcohol is not going to be 1 degree carbocation will not be very stable. So in the second step, what happens? There is the attack of nucleophile. Attack of nucleophile. So what is a nucleophile right now? The nucleophile is again the same alcohol. So this alcohol is going to attack on the protonated alcohol like this. This oxygen atom will be having a positive charge. Now you can see that this lone pair, the lone pair on the oxygen atom, it is going to attack on the alpha carbon. Okay, so one of the questions that students generally ask, or there is a doubt, sir, we have a positive charge here. So isn't the lone pair going to get attracted towards the positive charge, and isn't it going to attack on the oxygen atom itself rather than attacking on the alpha carbon? So the answer to that question is the oxygen atom is not going to accept any electron because it already has 8 electrons. That positive charge is just a formal positive charge. As you can see, how did it get the positive charge? Because it made a bond with H positive by using these 2 electrons. So this lone pair is still there. So when I have written 3 bonds, so we have 6 electrons, and there will be one more lone pair which is not used. So we already have 8 electrons in the oxygen atom, and the oxygen atom cannot hold more than 8 electrons because it is second period element which is having only 2 shells. In the first shell, you will be having only S. In the second shell, you will be having S and P. So S and P can hold only 8 electrons, right? P में 6 or S में 2. So the complete explanation why the oxygen atom does not get the electrons, rather the attack happens on the alpha carbon here. Now, as soon as this attack happens, the oxygen will take the electron density and leave as a water molecule. And we will rather get now, we see the 2 carbon atoms are as it is. This oxygen atom is as it is, which is what's having hydrogen. With one of its lone pair, it made a bond with carbon atom. So this is the carbon. So I will also make this carbon. Now this carbon is further, this bond has been broken, but it is attached with the previous carbon. So there are 2 carbons like this. Now this oxygen atom will again get a positive charge, right? Because it is making 3 bonds. Now the last step, the third step is deprotonation. Now in deprotonation, basically what happens, the hydrogen which is attached here, it breaks the bond with oxygen atom, and which gives you ether. So by the way, this is not hydrogen, which is going to give you ether plus H positive. Okay, sir, but why does hydrogen give its electron density? It does not actually. Hydrogen अपने आप ही electron density oxygen atom को नहीं दे देता. It does not give any electron density to oxygen atom. Rather, something comes and it takes away the hydrogen. So what it can be? It can be same thing, the alcohol. No, ये alcohol जो है ना, इस type there will be many alcohol present, right? So some of the alcohol has been converted to ether, but there are still many alcohol left in the reaction mixture. So one of the alcohol is going to come and abstract the hydrogen atom. Otherwise, the SO4 2 negative of H2SO4 can also abstract the hydrogen atom. Like no matter what is extracting the hydrogen atom, deprotonation is going to happen, and you will finally get an ether. Does this make sense? Yes or no? Please tell me.
Yes.
Chali, copy this down. Raise your hand once you're done. Everyone done? Write a few remarks. Write the first point. This reaction, it occurs via SN2 mechanism. Therefore, rate of reaction will be CH3OH 1 degree, 2 degree, and 3 degree will be the slowest. The second point is very important. 2 degree and 3 degree alcohols give significant amount of alkene. Significant amount of alkene with ether, as they are more hindered. Okay, therefore, it is not a suitable method for preparation of symmetrical ethers using 2 degree or 3 degree alcohols. Right, the third point. This method of preparation is not suitable for preparation of unsymmetrical ethers because it would need two different alcohols and lead to formation of mixture of ethers difficult to separate. Okay, copy this down. Then I will explain the last point. Why this particular method of preparation is not suitable for preparation of unsymmetrical ethers. Just waiting for Sadika. आराम से सारा ना फर्स्ट थोड़ा सा समझने की कोशिश कीजिएगा सभी कोई. ठीक है, ध्यान से देखिए जरा. Please try to understand. If we wanted to make CH3OCH3, then we have only methyl group. So for this, we would only take CH3OH and that will be fine. If I need two carbon atoms, O and two carbon atoms, this can be prepared by, there are two carbon atoms and then OH. If I want to make, for example, let's suppose even something is like this, then I just need one molecule, which is something like this. Okay. So all of these things are possible, but if I want to make something like this, two carbon atoms on one side of oxygen and one carbon atom on the other side. Now this particular ether can be made only by the mixture of two carbon atoms OH plus one carbon atom OH, CH3OH. Does this part make sense? Yes or no? Please tell me. If I want to make a, by the way, you can see that these these ethers are symmetrical in nature. That means whatever group is on the right side of the oxygen is also on the left side. Whatever is on the right and left, they are same. Left, right, and only the same. So we need only one alcohol molecule to prepare this particular ether. But if I have unsymmetrical ether in which one of the alkyl group is, for example, ethyl and the other is methyl, then I might have to take ethyl alcohol and methyl alcohol. Does it make sense? Yes or no? Please tell me.
Yes,
Yes,
sir.
sir.
Right? Now, let us suppose we have taken this ethyl alcohol and methyl alcohol, and what reaction can happen? So see, you have OH, that is ethyl alcohol. There will be CH3OH, which is methyl alcohol. And now we are going to react this with what? H plus H2SO4 at 413 Kelvin, the same conditions as we have been previously using. H2SO4 at 413 Kelvin. Okay. Now try to understand that there will be plenty of ethyl alcohol which will be only around ethyl alcohol. They will not even know that there is methyl alcohol in the solution. Does it make sense? Because there will be billions of ethyl and methyl alcohols. There will be some ethyl alcohol for sure, which will not even see methyl alcohol, which will not even know that there are methyl alcohol. They will be only surrounded by ethyl alcohol. Make sense? Yes or no, guys?
Yes, sir.
Right? So those ethyl alcohol are going to react with itself, leading to the formation of, I would say, 1,2 carbon atom oxygen and then 1,2 carbon atom oxygen. Similarly, there will be plenty of methyl, which will be only surrounded by methyl alcohol, and they will react with themselves as the previous reactions were happening. This like a reaction, and they will react with themselves, and they are going to react with themselves, and they are going to make CH3O CH3. Then there will be a few ethyl and methyl alcohol which are going to react with each other. and then they are going to form two carbon atom oxygen, and then we will get one carbon atom carbon, CH3. This is the required product. But what we have got two extra products. And obviously ethers is present, they will not be having a very much, they will not be having a large difference in the boiling point. So it will be very difficult to separate them by distillation or some simple methods. That is why we do not use this particular method of preparation for preparation of unsymmetrical ethers. Huh? For unsymmetrical ethers, we do not use the dehydration of alcohol as a method of preparation. Does this particular thing make sense? Yes or no? Please tell me.
Yes, sir.
Yes.
Right? Okay. But the question will be like this in your examination. When you pushing why this is not a good method of preparation, they will ask like this. This particular question is there in NCERT, if I remember correctly. Can you explain why bimolecular dehydration is not appropriate for the preparation of ethyl methyl ether? So they are not asking directly why unsymmetrical ethers cannot be prepared. They're saying bimolecular dehydration. Bimolecular का मतलब what? That means that you're going to use you're going to use what? Two alcohol for the preparation of ethyl methyl ether. Huh? So you are going to write the same thing as given here. Is not suitable for the preparation of ये लिख लीजिएगा because करके तो bimolecular dehydration is not an appropriate preparation for ethyl methyl because it would need two different alcohols and lead to formation of mixture of ethers difficult to separate. और उसके बाद फिर आप ये reaction इस तरह से लिख दीजिएगा. Does it make sense? Yes or no, please tell me, guys.
Yes, sir.
Yes, sir.
Yes, sir.
चलिए ठीक है. Copy this down. Raise your hand once you're done, and then you can write. You have to write only this reaction. उसके बाद आप लिख दीजिएगा. The second method of preparation that we are going to use is from alkyl halides, which is better known as Williamson ether synthesis. It's quite an important synthesis because it is having name in it. The name reaction is हमेशा important. I'm writing here, you can copy this down. When haloalkane is treated with suitable sodium alkoxide and SN2 reaction takes place, forming corresponding ether.
Sir,
Write this down.
क्या step हो जा सकते हैं?
ऊपर जी हाँ, है ना?
This reaction.
हो गया? Raise your hand once you're done, then you will see the reaction. Just waiting for you here. So in this case, we have to first of all understand what are the रिएक्टेंट्स यहाँ पे क्या है सबसे पहले ना, प्रोडक्ट तो हम लोग को ईथर मिलने वाला, बट व्हाट आर द रिएक्टेंट्स? So you see haloalkane is treated with suitable sodium alkoxide. Now this is something new that we have not heard of right now. You know, what is sodium alkoxide? We have seen this, that when you react alcohol, that is ROH, with active metals such as sodium, you get metal alkoxide. So you'll get RONA. The hydrogen will be replaced by sodium, and here you will get H2 gas. So this sodium alkoxide we have to use. So how are we going to use sodium alkoxide? See here. So you'll have RONA from the alcohol, plus you'll have some haloalkane, which will be having a general formula of R dash and halogen atom like this. And this halogen atom will be obviously having a delta positive charge, because halogen atom is more electronegative. It will be pulling electron density from the alkyl group. Now the oxygen atom of alkoxide, this is having lone pairs. So electron rich side, and this is electron poor side. So there can be an attack happening like this. Oxygen is going to attack on this alkyne group, and this particular halogen atom is going to go away as a leaving group. And it is an SN2 reaction, so this will happen in a single step. You will have R as it is, the O will be as it is, and Na, please remember, this is not a covalent bond. Na is having Na positive charge. यहाँ पे कोई bond नहीं है ना, it is just having positive charge. Oxygen as an atom is going to have a negative charge. तो यहाँ से आपको सीधा R dash में bond बन जाएगा like this. You will have R dash. Plus you will get NaX as a byproduct. ठीक है? Does this make sense? Yes or no, please tell me. क्या हो रहा है यहाँ पे?
Yes, sir.
Yes, sir.
ठीक है, प्लीज अच्छे से देखिएगा, यहाँ पे O है, OH वगैरह नहीं है, इस तरह का मिस्टेक्स खदीजा इस बार हम नहीं चाहते हैं। होपफुली थोड़ा आप अच्छे से करेंगे, राइट खदीजा?
Yes, sir.
ठीक है, चलिए, आई एम राइटिंग सम रिएक्शंस, अभी आप देखना चाहे तो देखिए प्लीज। सी हियर, सो व्हेन यू हैव टू कार्बन एटम्स एंड OH, like there are different ways in which this particular Williamson ether synthesis can be given. फर्स्ट स्टेप में सोडियम, सेकंड स्टेप में CH3Br. सो व्हाट यू नीड टू डू, देखिए आप बीच में ऑक्सीजन रखिएगा, हियर यू विल कीप द अल्काइल ग्रुप ऑफ अल्कोहल, हियर यू आर गोइंग टू कीप द अल्काइल ग्रुप ऑफ हैलोअल्केन. तो ऑक्सीजन आपने रख दिया ही, दो कार्बन एटम और ऑक्सीजन है आपके पास कहां से, अल्कोहल से, एंड हियर यू विल बी हैविंग वन कार्बन एटम फ्रॉम दी हैलोअल्केन CH3. ठीक है, सो दिस इज व्हाट यू आर गोइंग टू ऑलवेज डू. बाय द वे, दिस अल्कोहल हो सकता है, सोडियम अल्कोक्साइड भी हो सकता है. सो फॉर एग्जांपल यू कैन हैव समथिंग लाइक दिस ONA, you have sodium or alkoxide, plus you have two carbon atoms and Br. ठीक है, तो ऑक्सीजन तक तो वही लिखना बिल्कुल, एवरीथिंग एज इट इज टिल द ऑक्सीजन, जहां तक ऑक्सीजन है वहां तक बिल्कुल वैसे लिखिए आप ऑक्सीजन, एंड देन here you will attach whatever alkyl group is on the haloalkane. So haloalkane में कौन सा alkyl group है, two carbon atoms का, so one carbon atom and then two carbon atoms, right? Similarly you can have something like this also. Chlorine like this, oxygen, everything as it is still oxygen, and what alkyl group is here, two carbon atoms का alkyl group, so that will be attached on the oxygen atom like this. Does it make sense? Yes or no, please tell me.
Yes, sir.
हाँ जी बताएं.
Yes,
You
sir.
can have multiple examples है ना, इससे आपको घबराना नहीं है बिल्कुल भी. Everything as it is till the oxygen atom, and then what group is attached? Two carbon atoms to group. Try this one. Raise your hand once you're done. Send your answers on my WhatsApp. Very good, Mariam. Count the number of carbon atoms here in the product that we have made. Yeah, did you get your mistake?
जी सर, yes sir.
No, it's fine. What about others? Sadika and Khadija. भेज रहे हैं आप लोग?
Yes, sir.
हाँ, please send ना. Sadika, there is something wrong in your answer. Please see what it is. Just give me a second. Sadika, can you see there is something wrong in your answer?
Yes, sir, I got it.
Please correct it. Send it again. Khadija is waiting for your answer. आपने भेजा क्या?
Yes, sir.
मुझे भेजा भेजा. Very good, Khadija. That is correct. Sadika, please correct it. Send it again. Now it is fine. Very good. So everything as it is till the oxygen atom, and then the 3 carbon atoms will be there, right? Of the haloalkane. So please write the remarks. Remarks में ना आपको मतलब थोड़ा सा ध्यान रखना पड़ेगा because there are some theoretical points which will be applicable in reactions in the remarks. So the Williamson ether synthesis. is an SN2 reaction where alkoxide is nucleophile and haloalkane, the Rx, is substrate. ठीक है? अच्छा, SN2 के लिए तो बताइए, what is the reactivity of SN2? 1 degree is faster or 3 degree? If you remember, which is faster, 1 degree or 3 degree in SN2? In SN2, which is fast? Oh my God, मरियम खदीजा सदीका यही है, किसी को नहीं याद? What is faster in SN2? 1 degree or 3 degree? No idea. Okay, so 1 degree is faster, huh? So the substrate should be 1 degree. If the SN2 has to occur, the substrate should be 1 degree, that will be fastest. Okay, so therefore, or that we can say it should be less hindered. That is why the nucleophile can easily attack. This SN1 and SN2 key reactivity order should be memorized and by hearted. Just give me a second, guys. ठीक है, मरियम खदीजा सिद्दीका यही है, प्लीज SN1 और SN2 रिवाइज कर लीजिएगा हालोल्किन हालोरीन से. ठीक है, वो
Yes, sir.
those things
Yes,
should be memorized always. Therefore, the haloalkane should be less hindered. Should be less hindered. Second point, to form unsymmetrical ether, unsymmetrical ether, 1 degree halides, 1 degree haloalkane, 1 degree haloalkane should be used preferably. Third point, usage of 2 degree and 3 degree haloalkane leads to formation of alkene as they are more hindered. ठीक है, copy this down, then you will understand what this particular point is saying. Raise your hand once you're done. Siddhika, you're done?
No, sir, 1 second.
Okay.
Done, sir.
See here. Let's suppose we have to make something like this. Fine. Now, this particular ether can be prepared by two different, can be prepared by two different combination. Now, I hope you guys remember this is a retrosynthetic arrow, which means that this particular molecule can be prepared by. So what we can use is that ONA plus two carbon atoms and a Br or chlorine or iodine, anything. You know? Or what we can use is, this is Br plus two carbon atoms and ONA. This is also going to give you the same thing, right? Can you understand that both of these is going to give you same product on Williamson ether synthesis? Yes or no? Please tell me.
Yes, sir. Yes.
Yes,
But these are different reagents, right? Here we have 2-degree alkoxide. If you see here, this is a 2-degree alkoxide. And here we have a 1-degree alkoxide. Here we have a 1-degree haloalkane. Here we have a 2-degree haloalkane. Now we are expecting the same product, but what happens if you are going to use 1-degree haloalkane, then it is going to give you majorly, or rather I should say only one product, that is an ether. But if you're going to use a 2-degree haloalkane, then this oxygen atom, now it has a problem. What it will do, it is going to attack on this hydrogens. Is going to attack on these hydrogens. So दो तरीके से attack हो सकता है. Either it is going to attack on these hydrogens, abstract one of the hydrogen, acting like a base, or it can attack on the alkyl carbon. Both the attacks are happening. Both the attacks are possible. Both this hydrogen atom will be also having positive charge because it is indirectly connected with the halo. It is indirectly connected with bromine, which is more electronegative. ठीक है? So this oxygen atom, अब लेकिन hydrogen के साथ like the easier part for hydrogen is that it is very away, है ना? तो ये it is on the open. It is not hindered. It can be easily abstracted. So what is going to happen with the ether? There will be some ether for sure. You'll get some ether, but you will also get alkene. आपके पास क्या होगा? This oxygen atom is going to abstract, and you will get the 3-carbon atom alkene like this. Right? So in order to not get alkene as a byproduct, what we do, we do not use a 2-degree haloalkane. Rather, 1-degree haloalkanes are always preferred. अगर आपको, if you want a unsymmetrical ether, then always choose unhindered haloalkane. Haloalkane हमेशा unhindered रहना चाहिए. Does it make sense? Yes or no? Please tell me. आपसे पूछे ये आप कैसे बनाइएगा? Then you are going to use these reagents. ONA plus 2 carbon atoms Br, which is going to give you this type of ether. ठीक है? Copy this down. You can raise your hand once you're done. Siddiq, we're just waiting for you. Okay. Now, similarly, if I have any alkoxybenzene, right? So alkoxybenzene को भी prepare करने के हमारे पास दो मेथड हो सकते हैं. See, we can prepare it by using a sodium phenoxide and a haloalkane, or we can use a haloalkane and sodium alkoxide. What do you guys think? What should we use? Bond breaking की भी बारे में अगर आप थोड़ा सा अंदाजा लगाएंगे, then you will be able to answer it. See here. Here, this halogen atom will have lone pair electrons, and it is going to show resonance. And if it shows resonance with the benzene ring, this particular bond will be having partial double bond character. And as you can see, the halogen and benzene bond is always broken. Halogen or benzene, halogen hai nahi. So this bond has to be broken. But this bond cannot be broken very easily. Why? Because haloarenes, they do not show SN, nucleophilics. SN reaction wo dete hi nahi hai. That is why we cannot use these reagents. Rather, we have to use what? We have to use sodium phenoxide and haloalkane. So all of these theoretical questions can be asked. Why we cannot use haloarene for the preparation of alkoxybenzene? So what are we going to write? We're going to write like this. I'm typing it out, okay? Alkoxybenzene cannot be prepared using haloarene because haloarenes do not show SN. Hence, alkoxybenzene are prepared using phenoxide, or phenoxide will here chalega, sodium phenoxide specifically, phenoxide and haloalkane. Does this make sense? Yes or no? Please tell me.
Yes.
Raise your hand if you're done writing. Okay, here just waiting for you. Okay, yeah, are you done?
Yes, sir.
See here. So similarly, there are some other molecules which cannot be prepared. For example, uh, di-tert butyl ether cannot be prepared by Williamson ether synthesis because it requires a reaction of 3-degree haloalkane with 3-degree sodium alkoxide, which would lead to what? Which would lead to formation of alkene. ठीक है, तो बेसिकली आपके पास what you need to make a di-tert butyl ether. So what is di-tert butyl ether? So you have 1 2 3 carbon atoms and you have your oxygen, and you have 1 2 3 carbon atom and oxygen. So this can be only prepared if you have like this ONA plus Br. And again, now this oxygen atom, it will be very difficult for the oxygen atom to attack on this carbon atom. ऐसे बीच वाले कार्बन में अटैक करना बहुत मुश्किल होगा. So what it will do? It will react with one of the hydrogens which is present here. बीटा कार्बन के जो हाइड्रोजन है ना, उसको क्या करेगा? It is going to abstract the beta carbon hydrogen, and this hydrogen is going to form a bond like this. यहाँ पे और फिर इसका Br यहाँ से निकल जाएगा. So what happens here is, you see, when you have ONA and Br, you get alkene. You can copy this down. Everyone done? Okay. Another is you cannot prepare biphenyl ether. Biphenyl ether cannot be prepared using Williamson ether synthesis, as it would require a reaction of phenoxide with haloarine with haloarine, but haloarenes do not show SN. ठीक है. But what is biphenyl? This is biphenyl. Done, guys. Everyone is done. So now let us see some problems. They're asking, write names of reagents and equations for the preparation of following ethers via Williamson ether synthesis. A is 1-propoxypropane. Can you guys make 1-propoxypropane? ये 1-propoxypropane आपको बनाना है. I mean, what are the reagents you are going to use? So for that, you need to know how 1-propoxypropane will look like. Please send me on my WhatsApp 1-propoxypropane. The structure of 1-propoxypropane. If you don't know the structure of 1-propoxypropane, how will you be able to choose reagents? Okay, let me see here. Yes, very good. Yeah. Can you also tell me what are the reagents that you can use? What type of sodium alkoxide and what type of haloalkene are you going to use to prepare this? बाकी लोग को नहीं आ रहा प्रोपॉक्सी प्रोपेन है भैया? मरियम, सिद्दीका, किसी को नहीं आ रहा? खदीजा, व्हाट इज वन प्रोपॉक्सी प्रोपेन? सिद्दीका ने भेजा है। हाँ, दैट इज करेक्ट, वन प्रोपॉक्सी प्रोपेन। व्हाट अबाउट अदर्स? मरियम एंड खदीजा।
सर आई डोंट नो।
भाई कैसे चलेगा मरियम? नॉमेनक्लेचर नहीं आता क्या यार? है नॉमेनक्लेचर तो आना चाहिए ना। फर्स्ट ऑफ ऑल यू विल आइडेंटिफाई, आई डोंट नो वेयर टू स्टार्ट। अब नॉमेनक्लेचर नहीं आता तो प्लीज मैसेज मी, आई विल सेंड यू अ लेक्चर। इसमें नॉमेनक्लेचर आप पढ़िएगा फिर। 11th क्लास की चीजें हैं ये तो। वन प्रोपॉक्सी प्रोपेन, प्रोप है आपके पास, यू हैव 3 कार्बन एटम्स। ठीक है, यू हैव 3 कार्बन एटम्स एंड देन प्रोपॉक्सी ग्रुप इज ऑन दैट। तो प्रोपॉक्सी में यहाँ 3 कार्बन एटम्स के बाद ऑक्सीजन एंड देन अगेन 3 कार्बन एटम्स। So this is one propoxy propane. How are we going to prepare the one propoxy propane? What are the reagents we can use? एक आपको क्या चाहिए? Alkoxide, ONA, and then 3 carbon atoms का haloalkane, and you will get 1 to 3 carbon atom oxygen and 1 to 3 carbon atoms. ठीक है, चलिए देखिए तब, अगर आप लोगों को नहीं आया तो देखिए। सेकंड, प्लीज सी डोंट राइट एनीथिंग। आप लोग हम आराम से टाइम देंगे, कुछ नहीं देखना आपको। इथॉक्सी बेंजीन, प्लीज डोंट राइट एनीथिंग, प्लीज डोंट राइट। अभी आप लोग लिखिएगा, अल्लाह करे ना आए आपको। देख लीजिए पहले, उसके बाद लिखिएगा। See, 1-ethoxybenzene. First of all, you need to know what is the structure of 1-ethoxybenzene. So you'll have benzene ring and oxygen. So this is the benzene ring. अब इसमें ethoxy लगा हुआ है. So you'll have O, 1 carbon and 2 carbon. So ethyl group is there. So now please understand, you cannot use दो चीजें है ना, एक तो हमने पहले देखा हुआ है यहाँ पे ना, that alkoxybenzene. So this is ethoxybenzene. It should be prepared by sodium phenoxide. आपके पास होना ही चाहिए. So benzene ring and oxygen, this should be there, otherwise the reaction will not happen. So you'll have benzene ring, the oxygen atom here, and Na. Now what else is remaining? The 2 carbon atoms, and then benzene, the bromine group, and you will get the required material. ठीक है, ध्यान से देखिए जरा हम कर क्या रहे हैं ना, try to understand what is happening. Now next, the third is 2-methyl, 2-methoxy. अच्छा, methoxy पहले होगा वैसे। 2-methoxy, please don't write at anything. Please, 2-methoxy, 2-methyl. Propane. Now, what is the structure for this? So propane will be 3 carbon atoms. In the second carbon atom, you are going to have methoxy. So OCH3 will be in the second carbon atom, and there will be methyl, which is again CH3 here. अब यहाँ पे दो ऑप्शन है आपके पास again, right? So see how you have to do these type of problems. Identify the degree of alpha carbon. These are the 2 alpha carbons. इस alpha carbon की degree है 3 degree, and this carbon is 1 degree. And we have seen that if you are going to do Williamson ether synthesis, then you have to use to form unsymmetrical ethers of 1 degree haloalkane should be used preferably, or the haloalkane should be less hindered. The haloalkane should be less hindered. Less hindered का मतलब आप बताइए which one, 1 degree or 3 degree? Less hindered का मतलब क्या हुआ, 1 degree or 3 degree?
1 degree.
1 degree, very
1
good. So
degree.
haloalkane should be less hindered 1 degree. That means CH3 Br will be there, and the remaining part will be making the alkoxide, the 3 carbon atoms, the oxygen, the Na, and this is going to give you the required product, which is going to be 2-methyl and 2-methoxypropane, OCH3, like this. Similarly, if you have fourth one, that is methoxyethane. Methoxyethane. So the structure for methoxyethane is 2 carbon atoms, oxygen, and then 1 carbon atom. So this is the methoxy group, and this is the ethane. Now here, if you see this is also 1 degree, this is also 1 degree. But which is less hindered? This carbon atom does not have any other carbon. So less hindered will be always haloalkane. Less hindered, this will be ONA. Hamesha you have to choose a less hindered haloalkane for the preparation of ethers via Williamson ether synthesis. So 1 2 carbon atom, oxygen, and then 1 carbon atom. Does this make sense? All of these 4 questions, yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
The first problem that you are going to have is you will not know what is the ether you have to prepare. आपको नाम से structure लिखना नहीं आएगा ना, तो उस problem के लिए please message me on WhatsApp. I will send you a lecture on iPad common feature. I think last class में शायद यही आपने मांगा था ना?
जी सर.
आपने
लास्ट
देखा?
लास्ट क्लास में। हाँ मैंने देख लिया सर, एग्जाम में लिख लिया सर।
देखिए, इज इट हेल्पफुल?
यस सर, वेरी।
ऑल्सो या आई मीन, आपने उस तरह से आईयूपैक नॉमेनक्लेचर पहले नहीं पढ़ा होगा, राइट?
यस सर।
सो अगर अभी भी किसी को लगता है ना कि नहीं, हमने आई हैव ट्राइड आईयूपैक नॉमेनक्लेचर अ लॉट ऑफ टाइम बट कभी भी हमको नहीं आया, देन स्टिल आई वुड आस्क कि एक बार लास्ट ये है कि आप हमसे मैसेज कर लें, आई विल सेंड इट टू यू। You can, I mean, yeah, you can send it to your friends if somebody is struggling in IUPAC nomenclature, if they can find it helpful.
ओके सर, थैंक यू।
Everyone is done? Okay. Let's see if there is more questions. ठीक है, आज के लिए इतना ही। I mean, that is enough for you guys. और next class में we are going to see the physical and the chemical properties of ethers, and yeah, that will be the last class of ethers. We will be ending this chapter. ठीक है, और ethers में ठीक है, ज्यादा कुछ नहीं है। The last lecture will be ending with the ethers topic. ठीक है, so that's it for today. And one more thing is that I will be not taking your class the next Monday. तो उसके लिए ना will be compensating on Saturday and Sunday. ठीक है, does it make sense? मरियम, खदीजा, सदीका, यही?
Yes, sir.
यस सर।
ठीक है,
Yes, sir.
सैटरडे या संडे को आपकी एक्स्ट्रा क्लास होगी फिर। ओके, डू यू गाइस हैव हॉलिडे ऑन सैटरडे या ऑन संडे?
सैटरडे को होती है सर, सैटरडे को हॉलीडे रहती
एनी हु डज नॉट हैव हॉलिडे ऑन सैटरडे? हॉलिडे किसका नहीं होता है?
The holiday from school or tuition?
school
No, but I have school on Saturdays.
और ट्यूशन नहीं होता लेकिन आपका,
Tuition भी है यार. Yeah.
तो फिर आप स्कूल और ट्यूशन में हमको ऑप्शन क्यों दे रहे थे? यू शुड हैव सेड सर किसी में छुट्टी नहीं रहती है। अच्छा, एंड व्हाट टाइम डू यू गाइस कम बैक फ्रॉम स्कूल?
1
1 p.m.
p.m. KS.
1 p.m. कैसे? Anyone who comes home from school after 2 p.m. कैसे? No one. Okay, दो I think last है, right मरियम? यही
सर सर मेरा रहेगा शायद से, मुझे भी पक्का नहीं पता क्योंकि मेरे स्कूल वाले अब सैटरडे से एक्स्ट्रा क्लासेस रखते हैं।
So is it compulsory to take the extra classes at school?
यस,
Okay.
तो मेरा 3 बजे के बाद है